Welcome to S.E.A. Time. My name is Anjani Garib Singh, and today we are going to do something a little different in that we are going to look at some problems involving fractions. At the end of today's lesson, you'll be able to solve multi-step problems, not just single-step, but multi-step problems involving fractions, and you'd also be able to explain how you arrived at a particular answer. Now, regardless of what type of problem you have, whether the problem is simple or difficult, you have to engage in some kind of problem solving. You have to understand what the problem is asking you to do, you have to understand what is given to you, and you have to develop a strategy. So regardless of the problem, you have to do some problem solving. In the early 1900s, a gentleman called Poilier developed this four-step model for solving problems. In the first instance, you had to understand the problem. Now, understanding the problem is not simply reading the problem. You have to be able to restate the problem in your own words. You have to understand what is given to you, what you have to do. You have to understand the vocabulary that is being used in the problem. Some of you might want to underline key ideas in the problem to make sure that you keep track of what you are being asked to do. After you've understood the problem, it might mean rereading the question again, just to make sure. You make a plan. You have to have some kind of strategy. What am I going to do first? What do I do after? How would I arrive at my answer? After you made your plan, you follow that plan. Now, following the plan means that you have to be very, very careful, and you have to have patience, because a lot of the time the question doesn't finish in one step. So you have to make sure that you have executed the plan properly. If your plan doesn't work, you might need to go back and check your plan again. Maybe something is wrong with your plan and you have to use a different strategy. Or you might even have to go right back to the top where you have to read back the question and make sure you understand what you have to do. After you followed your plan and you arrived at a solution, you have to make sure that that solution is correct. So you would take your solution, put it back into your problem, and make sure that the solution works. You might have to use some estimation to determine whether your answer is a real life or a reasonable solution. You might have to use some mental strategies just to do a quick check back to make sure your answer is correct. If your answer is not correct, you may very well have to go back at the top where you have to reread the question and understand, make sure you understand. Or you might have to go back and change your plan. Your first plan didn't work, so you have to use another strategy, because a problem may not have only one way of working it out. And you would see when we start doing our problems that each question would have a number of different strategies that we can use. So this is our Poilier's four-step plan for solving problems. So now that we've gone through that, I want to spend some time looking at what kind of plans we could make. Making that plan, that is the crucial part of your problem. In the first instance, we look for a pattern. Now, looking for a pattern, what you find is that some problems lend themselves very easily to that first strategy of you looking for a pattern. Those questions where you have dots forming a pattern or you have numbers forming a pattern, that would automatically fall into the first category of looking for a pattern. Second strategy you could use is try smaller numbers. If the numbers are giving you problems, try smaller numbers. For example, if you have to add 600 and 300, the fact that you've put in 100 in this problem may prove to be difficult. So what you do is try simpler numbers. What about 6 and 3? So you make the problem simpler. The next one is make a model. Now, you might not be able to make a physical model, but you could certainly make an imaginary model or a virtual model in your mind and model the problem using that strategy. The fourth method is a guess and check. Sometimes your intuition or your common sense tells you that it's about this particular value, and you use your guess and check method. So you guess a value, and then you check to see if that value is correct. You will have to adjust your guess and make it bigger or make it smaller, but you could use a guess and check. That is another way that you could solve question. Make a list, a graph, or chart. Those questions that you have dots forming a pattern, you could say your first pattern use this number of dots. Second pattern uses this number of dots. So what you're doing is you're building a table or a list of the patterns. So that is another strategy that you can use. Create a number sentence. In the 2019 paper, there was a question where you had to find the length of a hall by lining up desk end to end. In that situation, to find the length of the hall, what you would have to do is to take the number of desks multiplied by the length of each desk, and you find the length of the hall. So that is creating a number sentence. The length of a desk multiplied by the number of desks is equal to the length of the hall. So you've created a number sentence. Work backwards. Sometimes the question might be better attacked from the backward end, and you work towards your answer. Use reasoning. You would have to analyze the problem, look at what you're given, how are we going to use what we're given to arrive at our answer. So there's a certain amount of reasoning that goes into the problem. Act it out. Again, in the 2019 paper, there was one question where two boys were turning. One was turning half a turn and the other one was doing a quarter turn in a clockwise direction. You could very well act that out in your mind. You could see Mike turning half turns and Joey turning quarter turns. So you could act it out as well. Draw a picture. Very often, a lot of the information, a lot of the words that sound confusing in a problem could be eliminated by simply drawing a picture. And we would show examples of drawing a picture to simplify the amount of words and the confusion that some of these words create. Use mental math. The mental math strategy, like I mentioned before, is a good way of checking back and reconfirming your answer. And the last one, use your fingers. Nothing wrong with using your fingers. I use my fingers all the time. So that is a valid strategy for solving questions. So I've given you your strategies, and we are going to see how we're going to use those strategies to solve problems. We start with the 2019 paper, and we start with the simpler problems, and gradually they're going to get more difficult. Remember, we are looking at questions involving fractions. The first question, write 39/5 as a mixed number. Remember the first step in Pollier's model? You have to understand the question. What do we mean by 39/5? We've divided wholes into fifths, and we have 39 of them. What do you understand by a mixed number? Remember what a mixed number was? A mixed number had a whole number part and a proper fraction. Very good. So we have to convert this fraction, this improper fraction, into a whole and a part. How do we know it was an improper fraction? Because the numerator was greater than the denominator. So we want to convert that into a number of wholes and parts. Now, I know some of you ready to go with that. There are different ways, again, of working the question. So now that we've understood the question, you have to develop whatever strategy you're going to use. Some of you would use an algorithm. You have an algorithm for doing this. You know what you have to do. Some other students would decide to use a practical approach. And what we have is we have 39/5. We know that every 5/5 would form a whole. So I divide the 39/5 into 5s. So I have 5, 10, 15, 20, 25, 30, 35. 35/5 giving me 7 wholes And after that, I would remain with the 4 to make my 39. So I have 35 at the top and 4 here to give me the 39/5 that I had initially. So I want to write that as a number of wholes. So I have 7 wholes and 4/5. So your answer, this is your algorithm. Some of you know right away from the time you see that 39/5, you're going to do a division of 39 by 5. And what you're doing essentially is you're doing the same thing. How many wholes you can have in your 39. So you're going to get 7 wholes with a remainder of 4. And we put the 4 divided by your 5. So that is not just 4, but 4/5. So your answer is going to be 7 and 4/5. So you could do it either practically like this, in which case you are building a model, or you could use your algorithm to get your answer as 7 and 4/5. You could verify. Remember, you have to back check your answer and make sure that it is correct. So you have another algorithm for converting 7 and 4/5 back into an improper fraction, just to make sure. Yes, we know it's a simple question, but we make errors. So we're making sure, so we multiply the 7 by the denominator. 7 5s are 35. We add the numerator 4, which would give us back our 39/5. So we know that our answer is correct. We sure that their answer is correct. So we've gone through all the steps of the polymer model. Remember what we did first was we tried to understand what was a mixed number, and then we develop a strategy. One strategy could be to use the algorithm, in which case you just divide by 5, or the other strategy is to build a virtual or a model in your mind where you group them in 5s, and then you get your answer. So that is your first question. The second question, there are no words, but again is a mathematical statement. You have to understand what the question is asking you to do. You have 5, and from that 5 wholes, and you minusing 3/4. Do you know how you can do that? So you understand the question. It's a simple statement. 5 minus 3/4 is equal to something. What is that something? There are different ways you can work the question. The first method, you could write your 5 as being 4 wholes plus 1 whole, and that 1 whole we would use to take the 3/4 from it. So we're writing the 5 as 4 plus 1, and this 1 we would use to do the subtraction of the 3/4, leaving the 4 alone, so the 4 would be standing alone. Our 1, we change it into quarters. 1 is how many quarters? How many quarters would make a whole? 4 quarters. So I have 4 quarters minus 3/4. Remember when we did subtraction of fractions, we checked to see if the denominators are the same. The denominators are in fact the same. So the subtraction would just involve subtraction of the numerators. 4 minus 3 would give us 1. So I will get 1/4 resulting from this, and we have the 4. So 4 plus 1/4. But that is not how we write a mixed number. We write a mixed number without the plus sign, so your answer is going to be 4 1/4. That is the first method. So if that was your plan, you've executed your plan, you've come up with an answer. We're going to check back now to see if our answer is correct. I have 4 1/4. If I add back my 3/4, do I get my 5? 1/4 plus 3/4 would give me a whole. A whole plus my 4 would give me my 5. Remember, we're verifying our answer. Yes, in our enthusiasm and in our glee, we might forget and make an error. So we're verifying and we're checking back. The second method involves changing your 5 wholes into quarters. Remember how many quarters make 1 whole? 4 quarters. So if you have 5 wholes, you're going to have the 4 quarters being represented 5 times. So you're going to have 4, 4, 4, 4, 4, giving you 20 quarters. When we're subtracting 2 fractions, we check to see if the denominators are the same. The denominator in one case is 4, the denominator in the other case is also 4. So we don't have a problem with different denominators. So we keep that denominator, and it's just a matter now of subtracting your numerators. So 20 minus 3 would give us 17. So you end up with 17 quarters. If you want to write that as a mixed number, 17 quarters, what you're taking is you're taking 4 quarters to make a whole. So out of that 17, 4 would give me 1 whole, another 4 would give me another whole, the third 4 would give me a whole, and the fourth 4 would take me to 16 quarters. So I would have 4 wholes, and I would have the 1 quarter remaining. So your answer is 4 1/4, just like you have gotten before. So what we're showing you is there are different ways of solving the same question. Your strategy would be different, but again, you could double check your answer. 4 1/4, if you add back your 3 quarters, we would get back the whole 5. So we are sure that the answer is correct. Next question. Again, shade the fraction on the second shape to complete the statement. Now, just like the question we did before where we had 5 minus 3/4, there's very little words in this question except that they're telling you that we have 2 shapes because they're talking about a second shape. We're trying to understand the question. Shade the fraction of the second shape to complete the statement. So this is a statement. It's a mathematical statement. And this plus something would give me that shape at the end. The shape at the end, you have the whole thing is being shaded. So you have this partial shading. Some amount has to be shaded in the second shape to give me 1 whole. Some of you could use a way of working out the question in that you know that this is 3 quarters. 3 quarters plus some amount would give me 1 whole. And you would know that from your addition of fraction, your addition facts. So some of you would know right away that what you have to shade is you have to shade 1/4 of the second shape. Now, the second shape is divided into smaller squares. How many smaller squares do you see in the second shape? Can you count it? We have 4 in the first row, 4 in the second row, 4 in the third row, and 4 in the fourth row. So we have how many? 16 squares, and we want to shade 1/4. 1/4 of 16 would be how many smaller squares? Yes, 1/4 of 16 is 4. So we know that we're going to shade 4 of these smaller squares. So if we shade this 1, 2, 3, 4, what you would get is you will get your quarter shaded, and you could see it visually. If I pull that quarter and I place it here, what you would end up with is you will end up with the last shape. So you could either do it visually, or you could do it where 3 quarters plus 1/4 would give you a whole. Again, you can see it. You could actually see that if you drag that quarter and you place it here, you're going to get a whole. So that is all that the question asks you to do, to shade the portion of the second shape that would give you your answer. So that is your answer. No words, no explanations. Those are that is your answer that you're looking for. 2019, we've gone back to the 2019 paper. This time is a little more involved. Remember, we started off with 1-mark questions. We're looking at 2-mark questions now. First step, remember what the first step in the Polyer's model was? Understand the problem. So we have to read the question and understand. S.E.A has 36 marbles. Very good. So we know Sita has some number of marbles, 36 marbles. She has 3/7 the number of marbles that Diana has. So Diana has another set of marbles. How many marbles do they have altogether? You understand the problem? Can we restate the problem in another way? Sita has 36 marbles. Diana has another number of marbles. We want to find out how many marbles do they have altogether. We also know that the 36 marbles that Sita has represents 3/7 of Diana's marbles. So what I've done is I've restated the problem in my own words for me to understand. What is my plan? Altogether is highlighted. You're seeing it in bold. So it means that we have to find out how many. We already know what Sita has. We have to find out how many Diana has so that we can add them together. All right? So that is the plan. We have to find some way of finding the number of marbles that Diana has, and we're going to add it to Sita's 36 to get the answer that we want. All right? So that is the plan. Find out how many Diana has, add it to Sita's 36, and we will come up with our answer. The first method we use, we know that Sita has 36 marbles. We know that that 36 is really 3/7 of Diana's marbles. So if that represents 3/7 of Diana's marbles, could you tell me what is 1/7 of Diana's marbles? What do you think we will do? If I want to find 1/7, I would divide this by 3. If I divide this side by 3, I will have to divide the other side by 3 as well. So we find that 1/7 of Diana's marbles would be 12. Remember what the plan was? The plan was to find the number of marbles that Diana has, so we could add it to Sita's 36 and we would answer our question. Now if 1/7 of Diana's marbles is 12, how much is her whole? How many sevens in a whole? 7 sevens. So that 12 would have to be multiplied by 7 to give us the whole number of marbles that Diana has. So we have that Diana has 84 marbles. Now remember, you have to be careful and make sure that you follow your plan. The plan was find the number of marbles that Diana has. Is my problem finished at that point? No, because the question asked you, how many marbles do they have all together? The number of marbles that they have all together, we have now the number of marbles that Diana has. We know how many Sita has. So we're going to add the 36 and the 84 to get the number of marbles that they have all together. And we have to be careful with our addition. Make sure 36 and 84, you can use some mental strategies to get 120. So the total number of marbles is 120. Now you make sure you go back to your question, make sure that is what you were asked to do, and you're finished. You say, right, we're finished. All right, there's another method that we can use. Remember, one of the strategies was we could draw a diagram. So we know Sita has 36 marbles, right? So that bar represents Sita's marbles. How many marbles did Sita have again? Sita had 36 marbles. So I could divide Sita's marble into 3 sections, all right? And Diana has, does Diana have more marbles than Sita or less marbles? What do you think? If you have 3/7 of somebody else's amount, the other person has more than you. So Diana's marbles would be more than Sita's marbles. Now, how much more we need to find out? You're told that Sita's marbles is 3/7 of Diana's marbles. So if I divide the number of marbles that Diana has into 7 pieces, what you find is that 3 of those 7 pieces would be equivalent to the amount that Sita has. Can you see that? You're told that 3 sevens, so I've divided Diana's marbles into sevens, 1, 2, 3, 4, 5, 6, 7. And 3 of those sevens, 1, 2, 3, is equivalent to S.E.A.'s marbles. We also have more information about S.E.A.'s marbles. We know that she had 36 marbles. And if we divide it into 3 equal pieces, how many each portion is worth? Each portion would be worth 12 marbles because she had to have 36 in all. Right, so you're seeing where we're going with this, all right? So if these are all 12s, then each one of Diana's portions, each one of those portions would also be 12. We want to find out how many marbles do they have all together. So together they have 10 of these little portions, these little 12 marble portions. So altogether they have 10 portions. Each portion is worth 12. So we multiply 10, multiply by 12 to get 120 marbles. You could have used that as well to work out, instead of going to this step, you could have worked out how many marbles Diana had right away, and you would have gotten 12, 12, 12, 12 7 times, which would have given you the same 84, and you add it to your 36 to get that. But I'm showing you this way because in this way, you don't really have to work out Diana's marbles. All you have to understand is that the number of portions you have altogether is 10 portions. Each portion is 12, so you have 120 marbles. Okay? All right, so that is how, I've showed you 2 methods, 2 different methods of working out this question. Next question, 2019 again. Can 2 fractions with the same numerator and different denominators be equal? Use words or diagrams to explain your answer. You may use a quarter and 1/8, but nobody is saying that you have to use a quarter and 1/8. They just suggested that you could use a quarter and 1/8. Do you understand what the question is asking you? Can 2 fractions with the same numerators and different denominators be equal? Could you think about 2 fractions that would have the same numerator? We're just dealing with the same numerator first. We're just talking about 2 fractions with the same numerator. How about 2/3 and 2/5? They have the same numerators, right? So you could think about an infinite number of fractions that have the same numerators and different denominators. So if we talk about 2/5 and 2/3, they have the same numerator and they have different denominators. So they qualify in our question. But what do these things suggest? When you get a denominator, what does that denominator tell you? So if I talk about 2/3, what does that denominator tell you? Your denominator tells you how many equal parts your whole was divided into. All right? So we're going to use that. So we're trying to make sure we understand the question. So you have the same numerators, but the denominators are different. What do you think your answer is going to be? Yes, I'm hearing you say no, but could you explain why? So your answer is no. Everybody agreed that they can't be the same. But the challenge is to explain why. Now you could draw a simple diagram where you have 2 identical shapes and you have shaded a quarter in one case and you have shaded 1/8. And by looking at it, you could see that they are not the same. Both drawings, this one shows a quarter, this one shows 1/8. These 2 fractions are not equal. Clearly, this area is larger than that area. We know that a quarter here is equivalent to 2 of those 8s. A quarter is equivalent to 2 8s. In that instance, therefore, a quarter cannot be equal to 1/8. All right, that's one way of looking at the question. An alternative solution is to think about what does the numerator suggest. The different denominator suggests that the whole, you have a whole, is divided into different number of equal parts. So example, if I have one whole and I divide it into 3 equal parts, I would get thirds. So I have 3 equal parts. If I divide each of those thirds into 3 equal parts, I will get 9 equal parts. So my denominator would give me an idea of how many equal parts I have divided my whole into. The numerator suggests the number of those unit fractions that you are counting. So if I am counting 2 of those fractions, I would say 2/3. If I'm counting 1 of those fractions, I would say 1/3. If I'm counting 2 of these fractions here, these are ninths, so I'm counting 2 ninths. So I'm counting 2 here, I'm counting 2 here, but clearly they are not the same because I have divided this into much more parts than this one. So the same numerator and different denominators always refer to different fractions because they are different number of parts that you have divided the whole into. You are counting the same number of parts, but the size of the parts will be different because you have divided them into different number of parts. Okay. S.E.A. 2018. Paula has 125 cupcakes of 3 different flavors: chocolate, strawberry, and vanilla. So she has 125 cupcakes. There are 45 strawberry cupcakes and an equal number of vanilla and chocolate cupcakes. What percentage of the cupcakes are vanilla flavored? So we're trying to understand the problem. She has 125 cupcakes altogether. Some are vanilla, some are chocolate, some are strawberry. We also know that there are 45 strawberry cupcakes. So if 45 of those cupcakes are strawberry, the rest should be vanilla and chocolate. All right? So what is the plan therefore? The plan is we must find the number of vanilla cupcakes and then convert that number into a percentage. All right? So the first thing we have to do is find the number of vanilla cupcakes, and then after that we would look at converting to a percentage. You remember how to convert a percentage. All right, so we will get to that in a little bit. So first of all, we're trying to find the number of vanilla cupcakes. So we started off with 125 cupcakes. 45 of them were strawberry. Remember we talked about how many strawberries. So if I take the 45 strawberry cupcakes away, the remainder would be vanilla and chocolate. So I have taken away the 45 and I've gotten 80. So I have 80 chocolate and vanilla. Remember, you are told that the number of vanilla and chocolate were the same. So if they are same, it means that we are dividing them, those 80 cupcakes, into 2 equal parts. 2 equal parts means we divide by 2. Very good. So the number of vanilla cupcakes would be 40. 80 divided by 2. How many chocolate cupcakes do we have then? I know it doesn't have anything to do with chocolate cupcakes, but you could tell me. We would also have 40 chocolate cupcakes because remember the number of vanilla and chocolates were the same. Now we have found the number of vanilla cupcakes. The problem is not finished because you were not asked to find the number of vanilla cupcakes. You were asked to find what percentage of the whole number of cupcakes would be vanilla. So we take those 40 divided by the whole number of cupcakes. We had 125 cupcakes altogether, and we multiply that by 100 and you would get 32%. All right, so we have 32% would be vanilla cupcakes. S.E.A. 2017 for 3 marks. 3 marks with 2 parts. Anjani shared a bag of mangoes with her friends. She gave 1/5 to Jenny and 1/3 of the remainder to Paul. So she took 1/5, gave it to Jenny, and whatever remained, she gave 1/3 of that to Paul. What fraction of the mangoes did Paul get? Can we say that Paul got 1/3 of the mangoes? No, Paul did not get 1/3. He got 1/3 of what remained after she gave Jenny the 1/5. So we first of all have to find out what she had remained after she gave Jenny 1/5. So a plan is forming in your mind. You have to find what remained, and once you find what remained, you take 1/3 of that to find out what Paul got. So you have an idea of where you're going. What fraction of the mangoes did Anjani give her friends? So we know that she gave 1/5 to Jenny. We would have worked out how much Paul got. So we just needed to add those 2 fractions. So the answer from here, plus the 1/5 that she gave to Jenny, would give us this answer. So you have developed your plan. You have understood your question, and you have developed a plan, right? The fact that you're talking about what we have to find, what remained after she gave Jenny the 1/5, means that you understood the question. So the first method involves finding how much remained after Jenny got her 1/5. So that would be how much Anjani remained with, and then we're going to find 1/3 of that remainder to get the fraction that Paul got. So Anjani gave 1/5 to Jenny, so that comes out. So she remained with 1 minus 1/5. Now if you have 1 whole minus 1/5, remember 1 whole is 5/5. 5/5 minus 1/5 would give us 4/5. So she remained with 4/5 of those mangoes. She's now going to give 1/3 of that 4/5 to Paul. So the fraction that Paul got was 1/3 of the 4/5. When you multiply your fractions, you multiply your numerator, you multiply by your denominator, so you get 4/15, and that is your answer for the first part. So Paul got 4/15 of the mangoes. In the second part, we wanted to find what fraction did her friends get. So we know we gave 1/5 to Jenny and 4/15 to Paul. So all we're going to do is we're going to add 1/5 to 4/15. So 1/5, if we convert to 15ths, 1/5 to 15ths, we're going to multiply the denominator by 3, and we're going to multiply the numerator by 3 as well. So I'll get 3/15 plus 4/15 would give us 7/15. So that is the fraction that she gave to her friends, 7/15. So that's the first method of working out that question. The second method is using a bar where we draw a model of the question. So that represents the number of mangoes that Anjani has. That's our whole. What happened is that she gave 1/5 to Jenny. So we divided the whole into 5 pieces. 1/5 went to Jenny. So this gray area is what was given to Jenny. Paul has to get 1/3 of the remainder, but the remainder is 4/5. How can I get 1/3 of that 4/5? What we do is we divide each of those 4/5 pieces. Each fifth we're going to divide into 3 equal pieces. So in effect, what we are going to do is we are going to divide the entire bar into 15 pieces. Jenny still got her 1/5. It's just that in this bar now, 1/5 represents 3/15. Paul is going to get 1/3 of the remainder. The remainder is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. 1/3 of those 12 pieces, 1/3 of 12 would be 4. So Paul is going to get 4 of those pieces. So Paul gets the blue area. So the fraction that Paul really got was 4 out of the 15 15 pieces, so his fraction would be 4/15. Now, the second part asks what fraction of the mangoes did she give to her friends? It is right there on the bar. This was given to Jenny, this was given to Paul. All we need to do is to add up how many we have. 1, 2, 3, 4, 5, 6, 7. You have 7/15 of the mangoes were given to her friends. All right? So we have two solutions. This one is using a bar model or drawing a diagram for the problem. A reasoning question. Peter spent 1/3 of his money on a toy car and 2/3 of his remainder on a toy boat. So he spent 1/3 of his money. He had a certain amount remaining. I am sure you know how much he has remaining. We just did one like that. So if he spent 1/3 of his money and then 2/3 of whatever remained on a toy boat, he had $6 left. How much money did he spend altogether? You understand the question. He spent 1/3 on a car and 2/3 of whatever he had remaining on a toy boat, and he still had $6 left. How much money did he spend altogether? So we're going to have to work out, after he bought his toy car, we're going to find out what remained. We're going to use 2/3 of whatever remained to find out how much he spent on his toy boat. All right? So after he bought his car and he bought his boat, he still had $6 remaining. So we're getting a plan. We have a plan of what it is we're going to do. So the first method, we know that he spent 1/3 on the car, so he would have been left with 1 minus 1/3. 1 being the whole amount of money he started with. 1 is 3/3. 3/3 minus 1/3 would give me 2/3. So this is the amount of money he had after he bought his toy car. He now used 2/3 of what remained on a toy boat, so he's taking 2/3 of this. 2/3 multiplied by 2/3. When we multiply fractions, we multiply the numerators, we multiply the denominators, so we end up with 4/9. So 1/3 was spent on a car, 4/9 was spent on his boat. So the total amount of money that he spent altogether would be the sum of 1/3 and 4/9. 1/3 could be changed into some number of nines. I'm going to have to multiply the denominator by 3. If I multiply the denominator by 3, I'm going to have to multiply the numerator by 3 as well. So 1/3 is really 3/9. The denominators are now the same, so I simply add the numerator, which is 7/9. So he has spent 7/9 of his money. Is that what the question asks you for? The question asks you how much money did he spend altogether. What we have is we have a fraction of the money that he spent. So we know that the remaining fraction that he is going to have, if he has 7/9 he spent on the car and the boat, he would now have only 2/9, because the whole amount minus your 7/9, the whole is 9/9. 9/9 minus 7/9 would give me 2/9, and those 2/9 would equal to $6. So if 2/9 is equal to $6, what would 1/9 be? I divide by 2, so 1/9 would be $3. Are we finished with the question? Remember, you have to be careful and you have to be dedicated to following the plan throughout. Be patient. We want to find out the total amount he spent. We know that he spent 7/9 of his money, and 1/9 is equal to $3. So 7 by $3 would give us $21 that he spent altogether. So that's the first method of doing the question. What we did was we work out how much was left after he spent the 1/3. We found 2/3 of that. We added the two of them to find the total fraction that was spent. So we got 7/9. And we found out that the remainder would have been 2/9, which was $6. So 1/9 would have been $3. And the total spent, therefore, would have been 7 times that $3, giving us our $21. All right, so that's the first method. The second method would be the bar model, where we're going to draw a diagram to represent the question. So this is the total amount of money that he had. 1/3 was spent on a toy car. So we divide the total amount of money into 3 equal parts, and that was gone on the car. He remained with 2/3. We are told that he spent 2/3 of that remainder on a toy boat. Now, how am I going to find 2/3 of that? I would have to divide each one of those pieces into 3. So I divide those into 3. I divide this into 3. So my bar is really divided into 9 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. He has already used up 3, which is 1/3. We want to get 2/3 of the remainder. The remainder is 1, 2, 3, 4, 5, 6. 2/3 of that remainder. 2/3 of 6 would be what? 2/3 of 6 would be 4 pieces. So he's going to use 4 pieces. 1, 2, 3, 4 pieces on his toy boat. So he uses 4 of them on his toy boat. He remains with 2/9. We know that 2/9 is $6. So 1/9 would be equal to $3. So the total amount he would have spent, if you count it, 1, 2, 3, 4, 5, 6, 7 9ths. 7 9ths. This is 7 by 3, which would give us the $21. So what you have is you have a drawing of the problem here using your bar model. So this is our second method for solving the question. Another question. Half of Isaiah's money is equal to 2/3 of Bob's money. Isaiah has $15 more than Bob. How much money do they have all together? Half of Isaiah's money is equal to 2/3 of Bob's money. Isaiah has $15 more than Bob. So they're telling you that Isaiah has more money than Bob. How much money do they have all together? So the plan is, if we could find out how much money Isaiah has, then we could work out how much money Bob has, and we could add the 2 of them. So let's see a diagram of the problem. All right, so we're going to do a drawing of the problem. Isaiah has some amount of money. We are told that half of Isaiah's money is equal to 2/3 of Bob's money. So what we do is we divide this bar into 4 pieces. And if we're talking about half of Isaiah's money, it would be 2 of the 4 pieces that we had here. And that is equal to 2/3 of Bob's money. So Bob has a certain amount of money. 2/3 of his money is equal to half of Isaiah's money. We are also told that Isaiah has $15 more than Bob. So this missing piece here is represented by $15. Now if you compare the 2 bars, what do you notice about that $15? That $15 is equivalent to 1/4 of Isaiah's money. Why? Because this bar stops across there. So let's see how we're going to use that. The total number of equal parts that we have, therefore, is 4 for Isaiah and 3 for Bob. So we have 7 equal parts. We want to find out how much money they have all together. All together, they have 7 equal parts. We know what is the value of each part. What is the value of each part? This 15 is equivalent to 1 of your parts. Each part is worth $15. So the total number of money that they have all together will be 15 multiplied by 7, which is $105. So what we've done is we've done a diagrammatic representation of the problem, and we come up with an answer of $105. The final question that we have is another reasoning question. In a jar filled with beads, 2/5 are blue and 1/3 are red. The rest are yellow and green. So we're trying to understand the question. How many colors of beads you have in that jar? We have 4 colors. We have blue, red, yellow, and green. All right? We are given how much blue, we are given how much red. So 2/5 are blue, 1/3 are red, the rest are yellow and green. The total number of red, green, and yellow is 126. All right? So we're getting some numbers. Initially, we're given some fractions. Now we are given some numbers. There are 3 times as many yellow beads as there are green beads. How many yellow beads are there altogether? Taking it step by step, we have 2/5 are blue, 1/3 are red. So we could find out what fraction would be yellow and green. All right? So how do we find out what fraction is yellow and green? We add those two, 2/5 and 1/3, and subtract it from 1. And we would get how much yellow and green. We are also told that there are 3 times more yellow than green. So in this fraction that we get here, 3/4 of it would be yellow and 1/4 would be green. So we're using, the strategy that we're using here is we're using a reasoning strategy. All right? We are also told that the total number of red, green, and yellow is 126. How many yellow beads there are? So we're going to use 2 different methods of solving. We know what fraction is represented by red and blue. So we added how much we had red and blue all together so that we could eventually find out how much yellow and green we have, right? Remember? We had 4 colors, red, blue, yellow, and green. So if I find out what fraction would be red and blue, then I should know what is yellow and green. Agreed? Think about it. Red and blue, the rest would be yellow and green. So I know 11/15 were red and blue, so how much would be yellow and green? How do I get that? I subtract it from 1. So yellow and green would be the remaining, so it would be 1 minus 11/15. Now, how much 15ths in a whole? A whole would have 15/15 minus 11/15 would give us 4/15. So 4/15 of our beads would be yellow and green. We are told that there are 3 times more yellow than green. So if I have 4/15 and 3 times more would be yellow than green, then 3 out of these would be yellow and 1 would be green. So yellow would be 3/15, green would be 1/15. So this is the crucial part of the question. You're told that there are 3 times more yellow than green. If together they represent 4/15, then 3 times would be 3/15 and the green would be 1/15. Do you now see that yellow is 3 times the green? Yes, because yellow is 3/15 and green is 1/15. We have another piece of information involving the 126 beads. We are told that red plus yellow plus green is 126. Yellow and green is 4/15. Red is 1/3. So 1/3 plus my 4/15 is equal to 126. 1/3 is 5/15. Yellow and green, we got to be 4/15. So 9/15 is 126. Okay? Are we done? No. we want to find out how many yellow beads we have. So if 9/15 is 126, and we know that yellow is supposed to be 3/15, what could I do with 9/15 to get 3/15? 9 to give me 3. I divide by 3. Very good. If I divide the 9/15 by 3, I'm going to have to divide 126 by 3 as well. So the number of yellow, therefore, is 126 divided by 3, which is 42. All right? So we let that soak a little bit, and we're going to look at it using another diagram. We're going to use a diagram model now, which is our bar model. The alternative solution, if we are talking about 3s and 5s, we divide our whole into 15 parts, because we were talking about the beads 1/3 and 2/5. So we look at dividing our bar into 15s. You are told that 2/5 are blue. 2/5 of 15 would give us how much? 6? 1, 2, 3, 4, 5, 6. So these are blue. 1/3 would be red. 1/3 of 15. 1/3 multiplied by 15 would give me 5. 1, 2, 3, 4, 5. These are red. The rest would be yellow and green. So the yellow and green would be these 1, 2, 3, 4. But we already know that the red, green, and yellow equal to 126. So when I add all of these, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 parts is equal to 126. Therefore, 1 part, 1/15, is equal to 126 divided by 9, which is 14 beads. And what the question asks you for is the amount of yellow. Now we know that there were 3 times as much yellow as green. So if this represents yellow and green, 3 of these would be yellow and only 1 would be green. So we take the 3 and multiply by each one, which we got was to be 14. So 14 by 3 would give you the number of yellow beads. So this is your bar model, using your bar model. All right? So this brings us to the end of today's session. I trust that you have enjoyed some of it. I bid you goodbye for today's session, and we'll see you around next time.